Hey guys, I had a little problem in the shop today with my compressor, and I figured I'd make a video to show you guys about it. Um, so I was just buffing something using air, and all of a sudden I see sparks coming out of the compressor motor, and it popped the breaker. So I was like, oh fuck, here we go. I figured maybe it's something I could fix, but I took it apart thinking maybe the starting device or something was bad, and found that the coil had like I don't know if you see the pieces of molten copper there or whatever, but the basically the coils are shorted in the side, so it would need to be recoiled, and figured that's probably cost more than the price of the whole motor. So I initially looked online to see if I could find this exact motor. You can buy them; they're about $400. But I find that's a bit steep, and I figured might not have a look online, see what I can find. There's not a lot. Like, everybody seems to be asking just about the price of a new one for old crappy motors, except for pool motors and well, actually hot tub motors. So I found two hot tub motors. This guy had his old school hot tub that had these two 7 horsepower motors, pumps. Most of the time they're only like 1 horsepower, 2 horsepower, but these two are actually 7. So I was thinking maybe I can make this work somehow with my compressor. This one's actually 5 horsepower, 220 or 230 single phase, and it's got pretty beefy starting. So I don't know if these pump motors can handle the starting current required to get one of these pumps going. I got a pretty big compressor here. It pushes out something around 18 CFM, I think. See there, 18.5 CFM at 100 PSI, and usually regulates from 110 to 140. And works really well normally. I can sandblast wide open with this, and never have to worry about running out of air. The compressor keeps up. So anyway, it's a pretty heavy head, and normally on over 5 horsepower you have magnetic starters. So that's the other thing. I might add a magnetic starter. This one probably should have had one anyway, and this might be part of the cause. Maybe the contacts on the pressure switch are starting to go and cause the coils to overheat. So I'm just gonna see if this thing can even turn the compressor, and if I can get it to go, I'll probably upgrade afterwards to a magnetic start system. But there's probably people having issues with their motors at one point in time and thinking, would I be able to put a pool or hot tub motor and would it work? So I thought it'd be an interesting video. It might not work, but I paid $50 for this one here. Actually 50 a piece he wanted, so $100 for both. But I didn't really need the second one. I figured since this is kind of experimental, I'll get 2, and if I burn up the first one, I'll make sure to maybe try something different on the second. So that's the plan, and I'll keep you guys. So I took, first of all, actually, might as well show you guys, I took the head off, and the way you get these off is you unbolt the cover that sits on top here, like this, and so you undo these screws, then you get access to the impeller. Then there's a million other videos on how to rebuild pumps, how to do this, but just so you get quick tutorial here. And then once you get the impeller, access to the impeller, then you need something to hold the shaft on the backside. And once you take the cover off the backside, you're left with a shaft with a slot in it. So you can hold it by the slot, or it was quite stuck on, so I actually had to take a pair of vice grips, put it on the shaft, and that way I was able to unscrew it. The shaft is in pretty rough shape underneath the seal area here. So let's see what I can do. I might have to pull the armature out and put this thing on the lathe. It's way smaller also, that's the other problem. So I was thinking, I knew it was going to be smaller, but I was thinking it was going to be slightly bigger, and I just put a small sleeve with a key in it to upsize it, because this thing is like freaking almost 3/4 of an inch, that the original one. So, but I think I might just machine. I have a lathe here, so I'll probably just machine a steel bushing and maybe remachine this, and I might actually weld it on. We'll see what I decide to do, but if I do that, obviously I'll have to slot it first and then maybe weld it on this shaft. If I think that it won't damage this armature. I think this is basically a permanent magnet armature, and there's nothing really that can melt on it, but I'll find out when I take it out anyways. So I'll keep posting, I'll add to this and show you guys later on how I do that. All right, here we are on the lathe. It's my old Logan lathe, pretty beat up old machine, but do a little stuff like this, it works pretty good. Anyway, so I just did a few passes on the shaft, and I didn't want to go too deep and remove everything because it's already kind of tiny. And now I know what size hole I'll need in my bushing. It's approximately 210 thou, or yeah, no, sorry, 408 thou there. So that's the width that I'll need, and I'll have to increase that quite a bit. So just thought I'd show you guys how I did that part to clean it up there. It's a pretty terrible looking shaft, but don't need to get too fancy with this, because for the job that is intended, I think this will be just fine. Okay, here we are back at the compressor. So I ran into some problems. Turns out the pump motor doesn't have enough starting current to turn this giant compressor head, which is not a surprise to me. But anyways, before I got to that part, I machined a bushing like a sleeve on my lathe there out of brass, and then I drilled, rather than making a key, which is a lot more work, I just drilled straight through. Before pressing it onto the shaft, I drilled a hole straight through, threaded it, and then I made like a nice indent with the drill also on the shaft, and then I screwed in that locking screw right there. So I made sure everything was machined like maybe like 3/4 thou smaller for the sleeves, so I ended up having to press it on with the press, which is what I wanted. I wanted a nice tight fit, which probably would be a pain in the ass to take it back off, but it's everything's tight, and the fact that this shaft is already too small, I figure any play in there could have it wobble and, you know, create more problems. So that's how I did that. Now, initially this motor had a very small start capacitor. It was like, if I remember correctly, somewhere around 30 microfarad. So obviously a water pump doesn't have as high starting current, so maybe that was okay for a water pump, you know, because it's only, I guess, spooling up a bit of water, and it doesn't really, it's not locked up as the pump starts, you know, inside of a water pump. So initially I tried putting the start capacitor that I had on my other motor on this start winding. So I had to open up the case, remove the original capacitor, and install the one I had on my other motor. And I was thinking that might do it, but turns out it helped a little bit. It got the motor to sort of turn. What was happening, as soon as I turned the breaker on, it would just it wouldn't even move. It would just buzz. So I turned it right off real quick, you know. and then I put the start capacitor on, tried it again, and I get like maybe like half a rotation. So it's like, okay, that's about as high as you could go for start capacity on a motor like this. I think it's about 240 microfarad, I think, this capacitor. I have to look to see, but it's somewhere between 210 and 240 anyway. So I can't really go any higher there. But then I thought, well, what if I would add a start capacitor to the main winding? Maybe I could get it to start and then disconnect it. So obviously this is all temporary here. I just doing some testing. And so I took the run capacitor off of the other pump that I picked up, because I got two. And that one's 50 microfarad. And I temporarily just plugged it into the main winding and turned the breaker on, and boom, I get a start. But obviously you can't leave that on all the time, or else it might run unbalanced. So I installed a little system here, because I use this compressor quite a bit, and I just wanted to get something going so I could use my air here until my magnetic starter arrives. And also I ordered a special hard start kit, which is actually made for AC system, but I'm gonna try to install it on this motor on the main winding. So you normally on the run, you'd have these two capacitors, which are 25 UF each. And then so just for the start, it adds in this 50 extra microfarads. So it gives you 100 total. And that's enough to get it to go. So what I did is I had these relays in my shop already for another project. So thought I'd put them to use for this temporarily. I basically am right now, like it is, this relay is powered, and as soon as I get power from the compressor, it basically powers shut this one here, which cuts out that relay. So, but it's also on a time delay. So it actually, as soon as it gets the input from the compressor motor wire, this wire here sends a power through this coil, and this is a 110 volt coil. So I ran it on one of the poles of the motor and to neutral. And the way it works is it basically powers the time delay relay off. So as soon as this gets power, it tells this one to turn off in about 2 seconds. So I'll demonstrate how that works. You can see with the lights how everything going on. So I can watch it, like as I use this compressor, I can check to make sure this light turns off after a few seconds to make sure nothing's welded shut here and I don't burn out something until all the rest of the parts arrive. But I'll show you basically how that works. So I'm gonna release some air from the compressor here, and you can watch as everything spools up. So you can see that little red light here. Let's see what happens. I already drained it a little bit, so we'll see. Should turn on any second here. See, time delay on, and it just turned on. The light turned on. So there you go. Got her going with a pump. So yes, or I should say, no, it doesn't normally work, but there's a way to get it to work, and we'll see how long it lasts. We'll get back to you in a minute. Here we are again looking at this compressor, and obviously, as you can see now, I've replaced that old pump motor with a brand new, well, it's been there for a little while now. I've been never finished that video. I probably filmed that like 6 months ago, but I thought I'd finish it off properly here. What happened is I ran that pump motor for about probably like 6 months, and eventually the shaft sheared. Like, so that tiny shaft, obviously I should have known, and I was actually intending on putting a sleeve in it, but you know how when something's going and you're working away, you kind of forget these things. And yeah, so one day I walk in the shop, a compressor kicks in, and the freaking the pump just stopped turning, and I look, and the freaking shaft is sheared. And the reason I didn't really bother fixing it too is because it was heating up, so it was getting too hot. Like this motor here, like if it runs through a full cycle or 2 in a row, I could still put my hand on it, but that one was just getting boiling hot, so I added all this crazy cooling here to the other one. And I even had, I think, another metal shroud pushing that air more tightly into the back end of that previous motor, so I can get as much air through as possible. And even with that, after like 3 cycles in a row, it was just, you know, it was just too hot, and you could tell it was overloaded. So I checked with an amp gauge up on my circuit breaker panel. I added a magnetic start to it, and even then it was drawing like more than the full load amperage rating on the motor. So I think it was rated at like 20 amps, and it was drawing like 25 amps under load. So that's probably why I just couldn't dissipate the heat. It was underpowered. This particular motor is a 5 horsepower, and the current rating on it is like, I think it's like 25 or 26 amps. I can't remember. The data plate is kind of hidden back there, but it's more than what that motor was saying. It was a 7 horsepower, but it was not a 7 horsepower. And really, the amp rating on the data plates, you're kind of like your telltale indication if they kind of over rated the horsepower rating on what they say it is. But if you look at a 5 horsepower motor and it says that it can, like, the max amp draw, the FLA amp, full load amperage is like only like 20 amps, it's not really a 5 horsepower motor. It's probably like 3.5, 4 horsepower. Now if you look at like this one, it's rated like 25 amps. That's right around 5 horsepower, and it's capable of cooling itself off. I left that fan on there because I thought that wasn't really a bad thing. It doesn't really look the greatest the way I got it set up now, but I got it on a timer. I reused some of the parts that I had on the pump motor and transferred them over to this fan. So basically it runs for about 7 minutes after the compressor shuts off, and if it keeps cycling, just keep running. So it has sufficient time to cool it off even after it shuts off. So I have a switch there. If I find this annoying, I can just turn that switch off and have it not run, you know, if I need to. If I find it's just too loud. It is a bit loud. That's an old fan out of a vent off of a stove, or actually I think it was like one of those microwaves that goes over the stove. So it was like a vent. It was a vent and a microwave. Anyway, so yeah, so it didn't really work out with that old motor, but it's a really interesting experiment. And you know, I didn't spend that much money. This magnetic start, I think, is going to be good that I got it anyway. It might make this motor last a little longer. It just has a really chunky relay in there, and when that thing kicks in, it really like gives all the current possible to that motor all in one shot.
So and the contacts in there are way more heavy duty. I think it's rated up to 10 horsepower, the magnetic start that I have there. So that should make everything work correctly. And yeah, so if you're wondering, like, you know, I could have maybe beefed up that shaft and have it not sheared, because when I took that motor apart, I saw that the shaft actually gets bigger as it gets to the core of the motor. So maybe there would have been a way I could have put a sleeve and welded it on the rest of the shaft, and then machined it back down to proper size. And I probably would have strengthened that shaft enough so it wouldn't have sheared, but overall it was underpowered anyway. So if ever you're wondering about that, that's my experiment, and that's how it all worked out for me. And hope you learned something from it. If you like this stuff, again, like, subscribe. Hopefully I can put some more stuff out there more often. The more subscribers I get, you never know, one day, and the video quality hopefully will improve over time. Thanks for watching.